Okay, well, today what we're gonna do is we are going to start a new chapter. And so remember, this whole unit is about trig stuff. And chapter 8 actually starts with trig stuff again. It's gonna look very similar. To something that we've dealt with before. So we're going to start looking at section 8.1, law of sines. Now, basically, this is going to be very, very similar to what we did in section 5.4, which was solving right triangles, okay? So we want to solve triangles that are not right triangles. Remember that when we had right triangles, we had three tools. One was that the angles had to add up to 180 degrees. The other was SOHCAHTOA. I'm just going to write SOHCAHTOA. And the other was the Pythagorean theorem. Which was a squared plus b squared equals c squared. Right, where c is the hypotenuse length and all that stuff. So that's just a short version of it. Okay. SOHCAHTOA and the Pythagorean theorem only work for right triangles. So we cannot use either SOHCAHTOA or Pythagorean theorem with triangles that aren't right. I'll just say non-right triangles. So we need to have other tools. By the way, we're going to see something later about SOHCAHTOA and about the Pythagorean theorem and how they connect to the law of sines and the law of cosines we're gonna do in A1 and A2. Okay. So basically, what we do is we replace these two rules with two other rules that are more general. Okay. So we say to solve any triangle, let me make sure any triangle. Solve any triangle. We can use the fact that the three angles of the triangle add up to 180 degrees. So any triangle that works for. That rule, we're all set, right? And we can use the law of sines. That's what 8.1 is about. And also we can use the law of cosines, which is 8.2. Okay. So we had three tools with right triangles, and now we're going to have three tools with any triangle. Okay, get that? So we're replacing these three tools with right triangles with those three tools with any triangle. All right? So let's explain the law of sines and what it is. First off, the law of sines says that for any triangle, labeled in the following way. So I'll just say for any triangle labeled like this. And you probably can figure out what our labels are going to be. The side lengths are going to be A, B, and C. And the angles opposite the side lengths are going to be alpha, beta, and gamma, the three Greek letters. So alpha is going to be the angle opposite A. Beta is going to be the angle opposite of B. And gamma is going to be the angle opposite of C. In a right triangle, gamma had to be 90 degrees. But now we're saying gamma can be any measurement. So we're going to label our triangles the same way we did earlier. That's what it comes down to. So for any triangle labeled like that, where alpha, A is the angle opposite of alpha, I misspoke. Sorry, alpha is the angle opposite of A. Then we have this property called the law of sines. And the law of sines says if I take the sine of angle alpha and divide it by A, I get the same thing as if I take the sine of angle beta and divide it by B, and I get the same thing as if I took the sine of angle gamma and divide it by C. Notice that generally speaking, the law of sines is always written this way. So generally speaking, the law of sines is always written this way, but you could separate each of these out into three different equations. You could have an equation for this pair, an equation for that pair, and then the equation for that pair. Okay, so we get essentially three equations there. Now, that's the tool that I'm going to focus on. I'm going to solve not right triangles. I'm going to solve any triangles, non-right triangles, with this. Law of sines. And the fact that the angles have to add up to 180 degrees. Okay. And I'll show you how we do that, how we use the law of sines to solve a right triangle. Or not, I keep saying right, a non-right triangle. You want to say non-right, I keep saying right. Excuse me. Non-right triangle. So let's solve the triangle. So let's say I have a triangle. I'm going to make up some values here. And again, we're just going to assume the labeling is like this. Always assume that the labeling is that. Does that make sense? Always assume that the labeling is this way. I'm never going to change that. It's never going to be the case that I'm going to have gamma opposite of B instead of gamma opposite of C. So every single triangle we deal with, both right triangles and non-right triangles, will have that. We'll have that labeling. All right. So solve the right triangle. Let's say we know side angle. So let's say we know A is 11.6, B is 15.4, and alpha is 32 degrees. Let's find the other measurements. So I know A is 11.6. I know B is 15.4. I'll figure out what C is. I know alpha is 32 degrees. I'll have to find what beta is, and I'll have to find what gamma is using law of sines and using the fact that angles add up to 180 degrees. Now, before we do anything, I want you to make sure your calculator is in degree mode. Once again, we're dealing with triangles, so we have to make sure that when we're dealing with degrees, our calculator is in degree mode. been in radian mode for all of chapter 7, basically, and all of chapter 6, basically. So make sure that we change back to degrees on these problems involving triangles. All right. So the first things first, I say, what tool should I use? I only have one angle right now. So I can't use the fact that the 3 angles add up to 180 degrees. Not yet anyways. So what I'm going to do is I'm going to look and notice that both A and alpha are given to me. In the law of sines, that's this ratio. The other thing that's given to me is the value of B. So if I look at this equation, the one involving these two, I have 3 out of the 4 missing values. Let me get that. So I'm going to set and use this part of the law of sines. Sine alpha over A is equal to sine beta over B. And then I'm going to plug in the A, the alpha, and I'm going to plug in the B. I'll multiply both sides by 15.4. Again, if my calculator is in degree mode, I can just type that in my calculator, 15.4 times sine of 32 divided by 11.6. I get like about 0.7035. Is the sine of beta. And so I find beta by taking the inverse sine of a number. And the way I do that in my calculator, I don't round that number, not yet. Don't round it to 0.70 yet. Just take inverse sine and then hit second and get your answer, right? So you guys know how to do that. Inverse sine and then second answer. So that puts in the exact value that you want. And I ended up getting 44.71 as my value for beta. Most times we're going to round everything to 2 decimal places. So I'm going to round that to 2 decimal places. My final answer anyways. Are you okay with that? Now I've found the beta. Now I go down to here. And I say, which one of these can I find now? I can't yet find the C. But I can find the gamma based on the fact that if you add up the angles, they should add up to 180 degrees. Right? So what I'm going to do is I'm going to now look at that. Now my angles I know have to add up to 180 degrees. I know alpha is 32. Now I know beta is 44.71. So I take 180 and I subtract 32 and I subtract 44.71 and I get 103.29 as my gamma. Does that make sense? That too, I didn't show all the steps, but you guys okay with that? That's just basically subtracting. So 103.29 degrees. Now the last thing to find is the value of C. And we're gonna have to once again use the law of sines, but this time I want to use gamma and C, one of the ones that involves gamma and C. Now you could use the equation that involves beta and B, or you can use the equation that involves alpha and A. All right, I probably would use the equation that involves alpha and A because those are the ones that are given to me. And I had to round to get beta. So I'll probably use the following equation. Sine alpha over A is equal to sine gamma over C. That way there's the least amount of rounding that I had to do. Does that make sense? I already rounded in order to find gamma through beta. So there we are. Sine, plug in 32 for alpha, 11.6 for A. Sine 103.29 divided by C, and then you can solve for C. Multiply both sides by C. And then multiply both sides by 11.6, divide both sides by sine of 32, or in other words, multiply by the reciprocal of that. I'm going to plug that into my calculator. 11.6 times sine of 103.29 divided by sine of 32. And I get about 21.30. So I go back and I say that side has to be about 21.3. By the way, the book goes through this a little bit more in detail. I'm not really concerned too much about the labeling structures, but this labeling structure, I was given A and then B and then an angle that's next to that B. So this is called a side-side angle structure. You're given two sides next to each other and then an angle. So as you're labeling it around, you go side, side, and then the angle next to it. So that's called a side-side angle. All right, any questions about that? Well, let's do this. I want you to try a similar problem. Let's say we want to solve this triangle. And we know that B is 26.8. Gamma is 52.1 degrees. And C is let's do 31.7 units. I want you to try to solve this triangle. It is a non-right triangle using the law of sines. And obviously the fact that angles that up to 180 degrees. So it's second and negative what?
Oh, okay. Thank you. I was hitting that, so that's why I was like,
Yeah.
okay. Second answer. Second.
lines. Let me go through, most people are doing pretty well on this, so let me go through the process. Hopefully you're going to, or you're thinking the same way. I have a B, a gamma, and a C. Because I have those three, I look to my law of sines and I say, I have a gamma and a C, so I have this ratio here. So I'm gonna use this ratio and I'm gonna set it equal to either this one or this one. Since I have the B, I'm gonna set it equal to this one. All right? And it doesn't matter if you write it the way I've written it over here, that sine of gamma over C is equal to sine beta over B, or if you write it sine beta over B is equal to sine gamma over C, right? You can flip the order, it doesn't matter. Then I plug in what I have. Sine of 52.1 over 31.7 is equal to sine of beta over 26.8. Multiply both sides by 26.8. And then I type that in on my calculator. And I ended up with 0.6671 and then some other stuff is equal to sine of beta. So if I take the inverse sine of whatever that number is, and again, I just do inverse sine in the second negative key for my answer. I end up with a beta that's 41.84, roughly. Oh, I should have wrote all that down. 1. Four. Now, as soon as I have two angles, I'm going to get the third by using the fact that the angles have to add up to 180 degrees, right? As soon as you have two, that's always the safe bet. Get the third by using the fact that the angles add up to 180 degrees. Don't know my alpha. I do know, now I know my beta. And I know my gamma. Subtracting from both sides, I get 86.06 as my alpha. Now that I have my alpha, I can use the law of sines along with either the beta and B combination or the gamma C combination to get my A. It doesn't matter which one you use, you will get very close. This is a rounded number. So when you use alpha beta, you might, did I say alpha beta? If you use B and beta along with alpha and A, you might get a slightly different number than if you used gamma and C along with alpha and A. That makes sense? So I think I'll use the non-rounded, meaning I'll use the sine of gamma over C is equal to sine of alpha over A. The only thing I don't know in that equation is the A. Gamma's 52.1. C is 31.7. And then alpha, now I know, is 86.06. I'm gonna do all this at once. Try to. If I multiply by A on both sides, and then multiply by 31.7 and then divide by sign. So multiply by A, and then multiply by the reciprocal of that fraction. I'm gonna get A is equal to 31.7 times sine of 86.06 divided by sine of 52.1. And I got 40.08 as my A. Is that right? By the way, this one again was sine angle. Or did I say side angle. Sometime today. Because you can see that the alpha is in between the B and the C, but I was given the B and the C, and then an angle next to, not the angle in between. Does that make sense? So it's the side C, side B, and then the angle, rotating around, right? So this is also a side angle labeling method. Like I said, let me do this. If I were to have used B and beta, you don't have to write this down. I would have still gotten 40.08 in this case, but you'll notice that the decimal versions of the one that I got with beta and B at the third decimal place is different than the decimal versions I got with gamma and C, all right? That tells me that some may be off by a little bit when I do the rounding. All right, so like some of my answers could be thrown off, but it won't be thrown off by very much, right? Maybe 100th or something like that, or a couple hundredths at the most. You get what I'm saying there? So rounded to 2 decimal places, we got the same. Rounded to 3 decimal places, one of them would have been 40.082, and the other one would have been 40.078. Right, so you can imagine a scenario in which that these numbers could be different by, a couple hundreds or something. That's all I'm trying to get at. Okay, so anytime we have this side angle, anytime we have two sides and the angle that we're given is not in between, that's basically what it is. So anytime we have two sides and the angle that I'm given is not in between. So if I have B and C and one of those angles, I'm good to go. If I have A and B and one of those angles, I'm good to go. If I have A and C and one of those angles, then I'm good to go. All right? I can do the exact same process using the law of sines. Anytime I have two sides and the angle that is not in between. That's called side angle. All right? Then the law of sines works. The laws, by the way, the reason for that is because we get a ratio anytime that happens. You get a single ratio. If you're given two sides and the angle in between, let's say I'm given A and C and then the angle beta, law of sines is going to be hard to use because I get one item. If I have the A, the C, and the beta, then I get one item from each case, from each ratio. And that's something we'll have to overcome. And the way we overcome that is with the law of cosines. You'll see that in a minute. However, anytime you're given two angles and a side, you can also use the law of sines. Anytime I have two angles and any side, I can use the law of sines. Here's how we deal with that. Let's say we want to solve a triangle. And let's say angle alpha is 45 degrees, angle beta is 72 degrees, and length of A is 104.6. So I know that A is 104.6. Alpha is equal to 45 degrees. Beta is equal to 72 degrees. What do you think the first thing I should do here is? Find your last angle. Exactly. Perfect. That's exactly what I was looking for. Find your last angle, right? Anytime you're given two angles, you should immediately say, I can find the third. And whenever you found two angles, go ahead and use the fact that the angles add up to 180 degrees to find the third. So alpha plus beta plus gamma is equal to 180. 45. 2. I got 63 degrees for my gamma. And then we're in a really good spot. Because now I have A and alpha, that's one of my ratios. And then I have a beta, and then I have a gamma. So I can use the A and the alpha with the beta, the B, to find the B. I can use the A and the alpha along with the gamma and the C to find the C. I'll use that part of the law of sines to find the B. Sine 45 over 104.6 is equal to sine 72 over B. And we've done this before, solving for B. I got 140.69, looks like. And then in order to find my C, you could use B and beta, but since I was given the A, since that B was rounded, I'll probably just use the sine alpha over A as the ratio I use to be equal to sine gamma over C. So after all the processing, C comes out to be 104.6 times the sine of 63 divided by the sine of 45. And that gives me a value of C, which is 131.80. These ones are always the ones that I like doing the best when you get two angles up front, because then it's like you find that third angle and just use the law of sines twice. You don't have to use inverse sine or anything like that. And there's not as much rounding either, because to find that third angle, there was no rounding that was needed. A lot of times with inverse sine, you need rounding, so. These are always the ones I like the best when you're given two angles in any side. Just find the third angle and then going through. Any questions about this? I want you to try one on your own and let's say that you know A is 16.7, beta is 49 degrees, gamma is 106 degrees. Find the other components. Everybody's getting these, so that's great. It's a lot, like I said, chapter 8, 8.1, 8.2, a lot more straightforward than chapter 7 was, right? A lot of options sometimes in chapter 7. For chapter 8.1 and 8.2, the options are kind of forced on you. If you're given 2 angles, find the third, right? So we'd say alpha plus 49 plus 106 is equal to 180. And you solve that for alpha, and you get an alpha of 25. So we know our angle alpha is 25 degrees, and then we turn to the law of sines. And because at this point I have A and alpha, I'll use my sine alpha over A ratio along with the sine beta over B to find the B. And then I'll use the sine alpha over A along with the sine gamma over C to find the C. So sine of 25 over 16.7 is equal to sine of 49 over B. So B is equal to 16.7 times sine 49 divided by sine 25. And when I did that, I ended up with 29.82. As my B. When I did the same thing to find C, by the way, hopefully you notice that if you're using alpha and A again, and you're trying to find C rather than B, the only thing that changes is the degree, or not the degree, I guess, the angle that you put into your sign in the numerator. So you can, if you want, hit second enter and just change the 49 to a 106 if you don't want to type in the whole thing again. You can type in the whole thing again, it's not a big deal, but it's not that much work. But once you see that, you can use your second enter key, change the 49 to a 106. And that gives me 37.98 as my value for C. So when we have two sides and an angle that's not in between, we use the law of sines. When we have two angles and any other side, and by the way, just so that if you read in the book, they talk about angle, side, angle, and then they talk about angle, angle, side. That just means you have two angles and a side. If you have two angles and the side in between those angles, that's angle, side, angle. If you have two angles and a side over here, that's angle, angle, side. Does that make sense? So the first one that we did was angle, angle, side, if you look back on it. This one is angle, side, angle, because we know the beta, we know the A, and then we know the angle on the other side. So this is angle, side, angle. In that case. Again, that's not super important to know for solving the right triangle, but if you read along in the book, they talk about, oh, which cases can you use the law of sines with? Well, anytime you have two angles and another side, you can use the law of sines along with the fact that angles add up to 180 degrees. Anytime we have side-side angle, you can use the law of sines. Okay. There are a couple of versions of solving the triangle that we can't do quite yet with the law of sines. And the two versions are when we have all three sides. If I have all three sides, then I have the A, the B, and the C. I have one of each of those. Okay? And so I can't get a ratio there. The other one is when I have a side length, the angle in between, and then another side length, because then I have one thing here, one thing here, one thing here, right? So if you're given three things, and one is here, one is here, one is here, then you're out of luck unless you have two angles, and then you can find a third pretty easy. So there's two options that we won't be able to use the law of sines completely to solve for. All right. And we'll get to those in just a minute. Now, before I move on past the law of sines, I do want to point one thing out. And this is more of just a general observation. So observation for sines. If, let's say, gamma is 90 degrees, then the law of sines says that sine alpha over A is equal to the sine of 90 degrees over, yeah, I'm thinking C. Is that okay? And sine beta over B is equal to sine of 90 degrees over C. Now, what is the sine of 90 degrees? 1. I get sine 90, you get 1. That's the right angle, okay? On the unit circle, we get to the point 0, 1. Second component, the y component on the unit circle would be 1. So you get 1. And if I multiply by A, that means sine of alpha is equal to A over C. And sine of beta is equal to B over C. Sine of alpha is equal to A over C if this is a 90-degree angle. What is C if gamma is 90 degrees? C is my hypotenuse. So the law of sines gives me back, essentially what this is this is the SOH part of SOHCAHTOA. We get that? So the law of sines is giving me back SOHCAHTOA in the case when gamma is 90 degrees. We follow that? So the law of sines, when we have a right angle, is essentially SOHCAHTOA. I'm not gonna, it's giving me the same information. And if you wanted to, it's kind of a messy thing to do, but if you wanted to, you could say, well, actually sine of alpha, if this is a right angle, has to be the same thing as cosine of beta. And so you get the CAH as well if you wanted to, from the same thing. Is that okay? And then if you do some other algebra, you get the TOA as well. Okay. You could say, oh, sine of beta is the same thing as cosine of alpha. If we have a right triangle, opposite over hypotenuse, adjacent over hypotenuse. And then you could write the tangent as sine over cosine and get your TOA part too. So law of sines is basically the generalized version of SOHCAHTOA. That makes sense? That's what the law of sines does. It's the general version of SOHCAHTOA. I'll just write that down. Law of sines is general version of SOHCAHTOA. Again, I'm not going to go through all the algebra. That will take a minute, but that's what I want to point out. So, from the law of sines and letting one of your angles be 90 degrees, you can get all the SOHCAHTOA equation. So once you know this, you can show SOHCAHTOA. All right. Oh, shoot. So let's move on to the next section, 8.2. And that's the law of cosines. Now, the law of cosines is messier. Not in the sense of how it's done, but it's just messier looking because there's more variables around. Okay. And what it is it's kind of like the Pythagorean theorem adjusted. So it's an adjusted version of the Pythagorean theorem. So the Pythagorean theorem, well, let me just say it this way. So here's what the law of sines says, law of cosines says. Law of cosines says that for any triangle, right or non-right, labeled in this way, then we get c squared is a squared plus b squared. That would be the Pythagorean theorem. And then we adjust it. The way we adjust it is we subtract 2ab times the cosine of gamma. So this gamma matches up with the c on the other side. So the angle we use is the angle opposite the length. Now you can actually do this for any of the sides or any of the angles. So you can do a squared is equal to b squared plus c squared minus 2bc times cosine of alpha. And again, notice that the a squared on one side matches up across with the angle that it's across from, alpha. And then you can do b squared is equal to a squared plus c squared minus 2ac times the cosine of beta. On your trig identity sheet, I probably don't list them off in this order. I probably go a squared, then b squared, then c squared, but. Now, this is a real quick, easy observation. What's cosine of 90 degrees? Sine is 1. Cosine of 90 degrees is 0. So if this happened to be a right angle, if this gamma happened to be a right angle, I can get 0 adjustment to the Pythagorean theorem. You see that? So it's like c squared is equal to a squared plus b squared minus this adjustment. But if I have a right angle, then all of this becomes 0. So that goes away, and I just get back my Pythagorean theorem. So law of cosines is the generalized version of the Pythagorean theorem. Or some people think of it as a Pythagorean theorem with an adjustment of -2 AB cosine gamma or something, or in this case, minus 2BC cosine alpha. So here's where this is needed. We're going to solve triangles. By the way, if I don't need to use the law of cosines, I'm not going to. If I can just do it with law of sines is going to be less calculator heavy, if that makes sense. So if I can just solve a triangle using law of sines, the fact that the angle's at 180 degrees, I'm going to do that. I'm going to ignore the law of cosines. But there are two situations that law of cosines are needed. The one situation that is needed is that if we have this labeling and we know A is 10.6, beta is 51 degrees, and C is 18.1. This is when we have a side, and then an angle, then a side. We have one angle that's in between the two sides. Will be it. Alpha yet. No gamma yet. Again, if I go back to the law of sines, I don't have a ratio that I can use because I have A but no alpha. I have beta but no beta. I have C but no gamma. So I don't have any one of those ratios fully. So I can't use the law of sines at this stage. So what I need to do is I need to look to my law of cosines and see which law of cosines can I use. Anybody see which law of cosines I can use right now and why?
Maybe the B squared equals A squared plus C squared.
Exactly. Yeah, it's the one with the B squared because that's the one that involves beta. So that's the one that involves beta. I have the A and the C, and so I have basically this entire right side of the law of cosines equaling B squared. So that's what I'm going to use. And I'm going to use that to find my B. Now that entire right side can be typed into my calculator. 10.6 squared plus 18.1 squared minus 2 times 10.6 times 18.1 times the cosine of 51. And as always, when we're dealing with triangles, make sure if we're in degrees that our calculator's in degree mode, right? That was true for the last section and this section. On the right side, I got about 198.49. I'm not gonna round that yet. Because that right side was equal to b squared. And so to undo the squared part, I'm gonna take a square root. And I can take the positive square root because we're talking about lengths here, right? So the lengths have to be positive. So just take a square root of that. And just like we've done a number of times before, I take square root and then I hit second the negative button. And that just gives me square root of my answer. And that's about 14.09. Is that right? Now at this point, we have one of two options. And I'm gonna always pick the easier of the options because that's what I like to do. You have A, B, and C, and beta. So because you have A, B, and C, you could actually, if you wanted to, find alpha based on this law of cosines, if you wanted to. They follow that? Because you already have A, B, C. So you could do all the work and find alpha that way. And you could do the same thing with gamma. You could find gamma using law of cosines if you wanted to. But that's actually usually more difficult. So I usually take the easier path, which is saying, now I have the B beta ratio for the law of sines. So I'm going to use the B beta ratio to find alpha using the law of sines. That's usually the easier way to do it. So in other words, sine alpha over A is equal to sine beta over B. I know A is 10.6. I know beta is 51 degrees. I know B now is about 14.09. And so I can figure what alpha is. I would multiply both sides by 10.6. And then say alpha is the inverse sine of whatever that number is. And type it in, 10.6 times sine of 51 degrees divided by 14.09. That's about 0.5847. And then I'll take inverse sine of that answer. And I got at 35.78. So my alpha is 35.78 degrees. Is that right? Now, lastly, I need to find gamma. At this point, I actually have three options if I wanted to. I can use this rule for law of cosines to find my gamma. I can use law of sines with sine alpha over A to find my gamma. Set that equal to sine gamma over C. Or the easiest way is to say I have two angles, three angles have to add up to 180 degrees, right? So I tend to choose the easiest path. If I have an option of choosing the hard path or the easy path, choose the easy path, right? Usually it's the least amount of work to say three angles add up to 180. I know alpha is 35.78. I know beta is 51. Let's find gamma. At 93.22. Everybody get that? So if I have two sides and the angle I'm given is in between, then I can go about this process. Let's do another one like that. Let's, well, first off, did everybody get that written down? I forgot to start erasing before I. Yeah. Okay. So let's say I know that A is 43, B is 78, and that gamma is, I'm going to say 83 degrees. I want you to try to solve that triangle using the law of sines and the law of cosines and the fact that the three angles have to add in 180. That's close enough. All right, this is the same basic process that we had last time. I'm given A, B, and gamma. So I would check my law of sines first. First off, I check the angles to see if I have two angles. If I ever have two angles, I fill in the third, right? By always go the path of least resistance. You know what I mean? Go the easiest path. If you have two angles, figure out the third. And then use law of sines to get whatever you're missing. But here I have gamma, B, and A, which means in law of sines, I got one piece of each ratio. So that means I have to turn to the law of cosines. Since I'm given the gamma, I'm going to use the c squared is equal to a squared plus b squared minus 2ab times cosine of gamma. A in this case is 43. B in this case is 78. And gamma is 83 degrees. When I typed all of that in, I got c squared is equal to 7115.50. And then I take the positive square root of both sides, because this has to be a length, has to be positive. And I got about 84.35 for my C. And at this point, again, I have A, B, C. I technically could use that to find my alpha if I wanted to, like that. But that's a pretty messy equation to use. I like using the law of sines better, if I can stand it. So I have this ratio in the law of sines, the ratio with the gamma and the C. I'll use that to find my alpha. Somebody else may have used that to find your beta. That's fine too, either way. But I'll use it to find my alpha. Sine alpha over 43 is equal to sine of 83 degrees divided by 84.35. When I multiplied both sides by 43, I ended up with about 0.50598, blah, blah, blah. And so we do the inverse sine to get the alpha. And then I got alpha as 30.40. Rounding to 2 decimal places. So everybody else got it? Are you good to go on that? As I was walking, I saw that. And again, you could do a great amount of work to get beta. You could throw all the things you know into here, solve for beta using this equation. Or you can use the law of sines for finding beta at this point. But probably the path of least resistance is just saying 3 angles. Now that I have 2, find the third. based on the fact that the three angles have to add up to 180 degrees. So I just take 180 minus 83 minus 30.4, and I get 66.6. degrees as my base. Any questions about having a side length or two side lengths and then the angle in between? This is called side angle side in the book. That scenario. Pretty straightforward that you have one component of each ratio of your law of sines. What to do. All right. Now there's one last version. One last version of solving a triangle that where you may need to use, well, where you have to use the law of cosines. Here's that version. Let's say I know all of the sides. I know A, let's just make this 105. B is 96. And C is 122. So I know all three side lengths. This is side, side, side. So if I know all three sides, then the law of sines isn't going to apply, because the law of sines, I need a ratio, and one of those ratios is always going to involve an angle, right? So the law of sines isn't going to work. The fact that the angles add up to 180 doesn't help me because I don't know any of the angles right now. So I'm going to have to use one of my law of cosines. Now, it doesn't actually matter which one you use. It's basically, picker's choice. Do you want to find the gamma first? Do you want to find the beta first? Or do you want to find the alpha first? Does not matter. I think I'll find the gamma. Is that right? And the only reason I chose gamma is so that I don't have to rewrite this on the board. Okay, that's the only reason. We already had the one up there for gamma, so might as well use the gamma. On a different day, if the previous example, I had used the one with the cosine of alpha, I'd probably use the alpha. The one involving alpha. So you just pick one of these, doesn't matter which one. And then I plug in my A, B, and C into this. So my C is 22. My A is 105. My B is 96. A again is 105. B again is 96. And now I'm gonna do some calculations. 122 squared is 14,884. 14,884. Running things. Notice how both of these are constants. So I'm just gonna add them up. 105 squared plus 96 squared. That gives me 20,241. This coefficient of cosine is 2 times 105 times 96. I should say -2 times 105 times 96. But I get 20160 minus 20160. And that's all being multiplied by the cosine of gamma. I would then subtract the constant from both sides, the 20,241. That gives me negative 5,357. Is equal to negative 20,160 times cosine gamma. Divide both sides by the negative 20,160. And I'm just gonna write it this way. 5357 over 20,160 is equal to cosine gamma. And the way I find gamma is I just do the inverse cosine. I got 74.59. So that's what gamma is, 74.59 degrees. Notice that took a minute to find gamma. There's some algebra involved there. Okay, and I gave pretty nice numbers. They weren't the nicest ever, but they were pretty nice whole numbers that we were using. You can imagine if you get into decimals, rounded to 2 decimal places, that gets pretty involved. Now, how am I going to find my alpha and my beta? I could do the exact same thing with this equation to find alpha, but that seems like a lot of work, right? I could do the exact same thing with this equation to find beta, but that seems like a lot of work. So what I would probably do is I would probably say, now I have gamma and C. So let's use the law of sines. Do you want to find alpha or beta first? Doesn't matter to me which one you want to find first.
Alpha.
Alpha, all right. So we'll go sine alpha over A. So given the, well, now I know the gamma is 74.59 degrees. I'm given that the C was 122. I want to find the alpha. And I was given that the A was 105. Whatever that number comes out to. I do sine inverse of that. I got 56.07. And then just like we did before, I'm going to use the path of least calculation to find my beta. And probably in this case, well, I'm sure in this case, it's the fact that the three angles add up to 180 degrees. So now that I have 56.07 is my alpha, and 74.59 as my gamma. I can use those to find beta. And it looks like 49.34 is my beta. Is that okay? Now, I just want to point out one thing. I originally solved for gamma, and then I solved for alpha, and then I solved for beta, right? If somebody else would have used the other law of cosines and solved for alpha first, and then used the law of sines to solve for beta, and then used the fact that the three angles add up to 180, their answers may be slightly off due to rounding, all right? So there's a couple of times in here, I rounded this number when I did my inverse cosine. And then I used that rounded number in here, and then rounded this number when I did my inverse sine. And then I used the fact that the three angles add up to 180. So if somebody would have solved for alpha first, and then beta, and then gamma, they might have gotten the answers that are really close to this, but might be just slightly off. Okay. Does that make sense? And that's perfectly fine to do if you want to solve for alpha and then beta and then gamma. Feel free to do so. All right. This will be the last one we do. Let's say we know A is 14, B is 17, and C is 10. Let's find the three angles in that triangle. Solve that triangle. Now, do you want to use gamma again, or do you want to use one or the other? Doesn't matter, that's all the same, right? It's all the same. I'll use a different one just because that'll be more confusing in your notes, right? You can use whatever one you want. You can use the one where it involves gamma, the one where it involves alpha, or the one where it involves beta. This time I'll use the one that involves alpha, I guess. Just to show you that it really doesn't matter. If you want to go through the whole process and solve for gamma first, by all means do that. So we have 14 squared is equal to 17 squared plus 10 squared minus 2 times 17 times 10 times cosine alpha. Oh, I should do. And then I turn my calculator. 14 squared is 196. 17 squared plus 10 squared is 398, or 389, excuse me, 389. There. 2 times 17 times 10 is 340. And so we would subtract 389 from both sides. That gives me negative 193 is equal to negative 340 times cosine alpha divided by negative 340. And then we do the cosine inverse of 193 over 340. You could use the decimal version of that if you like, it doesn't matter. And you get 55.41. As the alpha. So alpha is 55.41 degrees. And then I have a choice. Do I want to find beta next or do I want to find gamma next? And again, it doesn't matter. I think I'll go beta because that's the order. Sine alpha over A is equal to sine beta over B. So sine 55.41 degrees divided by 14 is equal to sine beta over 17. I don't know what that number is, but we'll figure it out. 17 times sine 55.41 divided by 14 gives me like 0.9996. Then take the sine inverse of that number. I got 88.47. That is my beta. If you know your alpha and your beta, the easiest way to find gamma is to note that those three numbers have to add up to 180. And so I get a gamma this time of 36.12. Now, like I said, I solve for alpha first and then beta and then gamma. If you would have solved for gamma first and then beta, then alpha, or gamma, then alpha, then beta, beta, then alpha, and gamma, these things might be off by just a little bit, by like rounding errors. Now, into Moodle, it is supposed to have programmed these such that if I solve for alpha and then beta and then gamma, and you write in those answers, or if somebody else solved for gamma first and then beta then alpha, and you write they wrote their answers, that they both be counted correct, as long as they're both, both legitimate options. So just be aware of that. So it should be set up, supposed to be set up that it all counts correct. But if you solve one way and you're pretty sure you got it right, and Moodle's saying that it's off by a little bit, just let me know and I'll check that out. But it should give you that play, right? That if you solved one way or the other way, both answers should be correct. Both answers should be counted as correct. All right, any questions about this? This is the case where, these are the cases where we use law of sines and law of cosines. If we have three sides or two sides and the angle between, then we can use law of cosines to get another thing. And then to me, usually the easier, once you've gotten one more piece of information, then you use the law of sines or the fact that 3 angles add up to 180 to get your other pieces of information. Okay. That makes sense. By the way, this is a weird thing. You had A and B, and you said gamma was, I'm going to put something else, 50 degrees. You could actually use law of cosines with this. Oh, I'm sorry, I screwed the thing up. I screwed it up. That's one of the ones we have to use law of cosines, right? Sorry. Let's say A, B, and alpha. A, B, and alpha. If I have A, B, and alpha, you can actually use law of cosines with this with a quadratic for C to solve for C. But then you have to use the quadratic formula, right? Which is a big hot mess too, but you guys understand what I'm saying there? So if you have those things, you could actually technically use law of cosines when I have side angle as well, but it's much more difficult, much more cumbersome to solve those. So usually if you have side angle, you want to use law of sines. Yeah, so I'm saying that to say, I try to do the easiest path on the boards all the time, okay? And if you can do law of sines, go ahead and use just law of sines. If you can do 2 angles and find a third by saying that they add up to 180, the 3 angles add up to 180, do that, right? So use the easiest path you can. And I've been trying to do that on the board. There are much harder paths though, if you really wanted to do some difficult paths. All right. So that's it. That's it for 8.1 and 8.2. And that's it for all of the material for this whole section, the trig stuff. I know we went pretty heavy into trig. It started back in chapter 5 with what angles were, and then solving right triangles. And then we did a lot of trig functions in chapter 6. And then a lot of trig identities and solving trig equations in chapter 7. And then lastly here, back to solving triangles that are not right triangles. So there's a lot of stuff on this test. That's another way of saying there's a lot of stuff on this test. Again, I'm going to give you till Sunday at 5 for the test, so I'll extend it a couple of days. Make sure you have whatever notes you need. Hopefully this chapter 8 stuff is pretty path-oriented compared to 7. So it's more, people usually like law of sines and law of cosines a lot better in chapter 7, just because chapter 7 you got a million different bunch of different identities to deal with. Chapter 8 is a little bit easier to see what you need to do next. So, all right. Well, anyways, test Sunday at 5, and then I will see you all next week.